Photon. The definition of photon is an elementary particle representing a quantum of light or other electromagnetic radiation. A photon carries energy proportional to the radiation frequency but has no zero rest mass. It always moves at the speed of light in a vacuum. The fundamental characteristics of a photon are its energy E and momentum P. Here we say photon is an elementary particle. What is called elementary particle? We know that from particle physics, elementary particle or fundamental particle is a subatomic particle with no substructure, thus not composed of other particles. That is, we know that elementary particles. What is elementary particles? Okay, in particle physics, an elementary particle or fundamental particle is a subatomic particle with no substructure, thus not composed of other particles. Here we say that an elementary particle or fundamental particle is a subatomic particle. What is subatomic particle? We say that subatomic particles means smaller than atom. Subatomic particle means smaller than atom. The total result is elementary. Photon is an elementary particle, and the elementary particle is a fundamental particle that is subatomic particle, that is smaller than atom. So the photon is an elementary particle, means the fundamental particle which is smaller than atom. So then we can say elementary particle representing a quantum of light, okay, or other electromagnetic radiation that represent a quantum of light or other electromagnetic radiation. It represents electromagnetic radiation and quantum of light. So this is the definition. A photon carries energy proportional to the radiation frequency, okay, but has no zero rest mass. We know that E equals H nu. Here we say a photon carries energy proportional to the radiation frequency. Okay, this energy is proportional to the radiation frequency. So a photon carries energy which is proportional to the radiation frequency but has no zero rest mass. We see that in the next. It always moves at the speed of light in a vacuum. The fundamental characteristics of a photon are its energy E and momentum P. Okay, we see that. Okay, we know that E equals H nu. Okay, E equals H nu. We also know nu equals C upon lambda, where C is the velocity of light and lambda is the wavelength. Okay, we also know from the Einstein's formula, E equals mc squared. Okay, C and 1c get cancelled. Okay, we get mc. What is mc? mc is the momentum, h upon lambda. mc is the momentum, that is equal to p. P is momentum. P denotes momentum. Okay, equals h upon lambda. We we take 2 pi. Okay, here then we get P equals h upon twice pi is nothing but h cut, and 2 pi upon lambda is nothing but k. That is k is the wave vector. Okay, we see that. Okay, here we write h cut equals h upon twice pi, and h cut equals h upon twice pi, and 2 pi upon lambda equals k. This is the wave vector. Okay, then we see that this is the momentum equals h cut into k. Okay, so then we can say the momentum vector p of a photon has a direction coinciding with that of the wave vector. The direction of p and the direction of k coincide each other. So we can say the momentum vector p of a photon has a direction coinciding with that of the wave vector, coinciding with that of the wave vector, that is k. Okay, we see that k is equal to 2 pi upon lambda. That is, k has a number magnitude, that is 2 pi upon lambda. Okay, and we also see that k has a direction, and we see that, and we also notice that k has a direction coinciding we can write coinciding with that of wave velocity. So we can see the direction of p coincide with k, and the direction of k is coinciding with the wave velocity. This is the relation. Okay, and what is the mass of the photon? We see that mc is equal to h upon lambda. Okay, and we also see E equals h nu, and E equals mc squared. From here we can write the formula: c squared is equal to h nu upon m, or m equals we see, therefore we see m equals h nu upon c squared. This is the photon mass. Or mass of the photon is m equals h nu upon c squared. This is the mass of the photon. Okay, we write m equals h nu upon c squared. Okay, then we can say photon mass. This is the photon mass. This is nothing but the mass of the electromagnetic field, and it is not associated with rest mass, because photons at rest do not exist. Okay, photon mass. This is the photon mass. Okay, photon mass m equals photon mass equals photon mass. Okay, তাহলে আমরা বলবো photon mass is the mass of the electromagnetic field, okay, and is not okay, and is not associated with a rest mass, because when C is equal to 0, the mass is equal to 0. Here we see when C is equal to 0, M equals also 0. M equals 0 or infinity, we say that. So or that is M equals infinity, that is not exist in the nature. We cannot say that that particle has the when the velocity c equals 0, that particle have the mass infinity. We cannot say that. Okay, M equals infinity, that is infinity, a rest mass, because photons at rest do not exist. Because photons at rest do not exist. Here we see that when c equals 0, M tends to infinity. When M tends to infinity, we cannot find them. Okay, take a rest. Okay, now we discuss about properties of photons. Okay, the basic properties of photons are, okay, they have 0 rest mass and rest energy. They only exist as moving particles. Here we see that when c is equal to 0, M equals infinity, M tends to infinity. That cannot be true. So we can say that they have 0 rest mass and rest energy. They only exist as moving particles. Okay, they cannot be stationary. Okay, so they exist only as moving particles. This is the properties of photons. Okay, they are elementary particles despite lacking rest mass. Okay, elementary particles despite lacking rest mass. Okay, then the third, they have no electric charge. The charge of photons is never exist. Okay, they have no electric charge. They are stable. Okay, the photons are stable. They can have interactions with other particles such as electrons, such as the Compton effect. Okay, then we see that they are spin one particles which make them bosons. They carry energy and momentum which are dependent on the frequency. Okay, আমরা momentum দেখেছি. What is the momentum? Okay, this is the momentum P equals, okay, h भाग lambda 2 pi upon 2 pi, that is equal to, this is the momentum. Okay, carry energy and momentum which are dependent on the frequency. Here carry energy, that is dependent on the frequency, radiation frequency. They can be destroyed or created by many natural processes. For instance, when radiation is absorbed or emitted. We see in the next, in the absorption part in laser, we see that the radiation when absorption is occurred, then the photon is destroyed. Okay, when in empty space they travel at the speed of light. This is the basic properties of photons. Okay, we see that when in empty space they travel at the speed of light, that is nothing but 3 × 10⁸ meter per second. Okay, speed, that is the speed of light. This is the basic properties of photons. Okay, and we now talk about how can we create photons. Okay, or how can be photon created. It's okay. This is the burst of light emitted by atoms. Okay, we see, or we can say that photons are emitted by individual atoms. Here an atoms, here an atoms, here an atom, and here an atoms. Okay, they emit photons. Okay, we can say an atom leaving an excited state gives up the excess energy in the form of burst of light. That is burst of light. When an atom goes to the higher energy level, and that meantime 10 to the power minus 8 second, it goes to the lower energy level and it gives us a photon, that is the burst of light emitted by atoms. Okay, the process of transition of the atom from an upper state to the lower state for a beep of time about 10 to the power minus 8 second, we already tell it. Okay, therefore the light emitted by an atom is not continuous harmonic wave. Okay, this is a atom, this is B atom, this is the C atom. Here when A atoms produce an burst, after sometimes B atoms produce a burst that is independent of these atoms produce the photons is independent of A. So this is the random process. It doesn't depend, the photon emission by A is not dependent on A or is not dependent on C. This is a random process. Okay, so this as it is a random process, it cannot be a harmonic wave. Okay, continuous harmonic wave, it is not a continuous harmonic wave. It is impossible to say exactly when an atom may emit light because the process is random. We can say it already. Okay, we see okay, then we figure out the process as, okay, this is an atom, burst a photon. Okay, this goes down, and then atom emit a photon, then it goes down. Okay, this picture says that the emission of light by a single atom, this is A atom, this is B atom, in terms of wave trains, this is a wave train, this is a train, this is a train, this makes a big train, this makes an big train. Okay, this is one, this is one, we let, and this is one we let, and this combine a train, this combine as a train, that is a wave train or photon train, we can say. Okay, this is a wave train. Okay, other atoms, in when these atoms emit a photon, then after a time B atom emit a photon. After some time B atom emit a photon, and this combine make a wave train. Okay, we see that. So we can say that figure 2, a succession of wave trains gives an impression of continuous wave. Impression of continuous wave. Okay, this gives us a continuous wave. Okay, Okay, we see that figure 2 pictorially describes the emission of light by a single atom. Okay, by a single atom in terms of wave trains. Other atoms in the source behave similarly but with different emission times. This is the different wave, different times. Okay, other atoms in the source behave similarly but with different emission times. Okay, adding together the wave trains generated by all atoms in the light source produces a succession of wave trains which gives an impression of continuous wave, which gives us, okay, gives an impression of continuous wave. Okay, this A atom, this is B atom. Then when we combine this, we get a wave train that gives an impression of continuous wave. Then we see that this is light wave. Okay, we figure out this. A atom in the lower state goes to the higher state and then goes to the lower state by emitting a photon. Then after that time an atom also emit a photon. We figure out this, and this combine in the source. There is a lot number of atoms in the source, so we add them. We add together, that is the wave train, and we get a continuous wave. This is the source of light. Here a number of atoms in that source goes to the upper state and it goes to the lower state, that is 10 to the power minus 8 second, and emit a photon. This is the photon. This is nothing but a photon. Light is nothing but a photon. Okay, this is a photon. And in the meantime there are a number of atoms in that source and produce same emission, and we add them and we get an impression of continuous wave. This is the source of light and a number of atoms in that source. This is the photon concept. Okay, thank you.